we want to convince ourselves that this map at, which takes an element of the Lie algebra and maps it to at x, which is itself a map from the Lie algebra to the Lie algebra, so it takes some other Lie algebra element and maps it to the Lie bracket. We want to show that this thing is actually a representation of the Lie algebra, in this case on the Lie algebra. So to this end we look at the commutator of these maps at x and at y. And in order to be able to write this down, let's apply this to some element z of the Lie algebra. Then we get, so this is at x of at y of z minus at y of at x of z. Okay, so what's that? That's the commutator. So this here is the commutator of y and z. And then we take the result, and of that the commutator with x. So it's, or rather the Lie bracket. It's x, and then we have yz. And here we have it the other way round. We have y with x, z. Now we can trade this minus sign for the order of terms here in this last commutator. So this is x with y and z. I keep saying commutator for the Lie bracket. You can just exchange the terms at the cost of an I. Okay, and here is a plus. And now we write y with z and x. Good. What have we achieved by this? Well, this is x, y, z. And now this is the cyclic permutation of it, x, y, z. So we know that by the Jacobi identity, if we add the third cyclic permutation, the thing is 0. So this is, according to the Jacobi identity, this is minus the third cyclic permutation, z with, what is it, x and y. Okay, and now let's use this minus sign here and exchange these two terms. Then we have x with y, commutator with z. But that's by definition at of xy applied to z. So we see that actually the representation of this here, of this Lie bracket, is just the commutator of these at x, at y things. So it is a representation. And now, what do the representation matrices look like? If this is a basis of the Lie algebra, the xj is here, then let's look at xj applied to xk. So this is a linear combination of the x's again, since they are a basis, and the result is in the Lie algebra. So we sum over L, xl, and what are the coefficients? The coefficients are the matrix elements of this at xj thing here, matrix element Lk of at xj. Now, on the other hand, we know how this is defined. It's xj with xk, the Lie bracket, but that's just sum over L. And now here come the structure constants, CL, JK, XL. And now we can compare here and here. The structure constants are the matrix elements of this representation.